Okay, so now we're moving on to inequalities and how to graph inequalities, but this time with two variables. So what is an inequality with two variables? Well, it basically just has x and y. So instead of just having, x is greater than 5 or y is less than 6, we'll have like x plus y is greater than 5. So it can be written in a number of different ways. So for example, it could be, some number a times x plus some number b times y is less than c. Right? It could also be less than or equal to some number c. Can also be greater than. Could also be greater than or equal to. But the key thing here is you see it's x and y together. And what happens is we're going to be basically figuring out what ordered pairs make the inequality true to talk about the solution of an inequality in two variables. So it's, again, an ordered pair, x, y, that makes the inequality true. And what's neat about inequalities is because we're dealing with less than and greater than, we're opening up the field to not just, one single point, but it could be a number of points. So we can check the way we did with regular equations, and then when we graph, you're going to see how that changes the way the graph looks. Okay? So look at example A. I want to tell if an ordered pair is a solution to inequality, and same deal as with our equations, all we're going to do is plug it in and see if it's true. So I'm going to take that 3, plug in -2 for x, minus 2 for y, and is that less than or equal to 2? So hopefully this part is pretty familiar, right? If it's true, it checks. So yes, it is a solution. Remember, just like before, finish it off by giving me that final statement. Don't just leave it as a check or an X, but tell me what it means, right? Same deal here. I'm going to plug in 1 for X, minus, and be careful here, it's a minus in the equation and then a -1 after that. So don't lose that second negative, which a lot of us tend to do. So 4 plus 1, is that greater than or equal to 5? Yes, it is, because 5 is equal to 5. So 1, -1 is a solution. Okay? Finally here, let's at C, plugging in -1 for x, 9 for y. -1 minus 27 is clearly going to be not, larger than 8 because this is going to be a -28. So this is false, meaning -1, 9 is not a solution. Okay? So hopefully a nice, easy way to ease into inequality, something that we're familiar with here, just plugging in x and y. Go ahead and try those 4. You try problems for me and see, do they all work? Does one work? Right? What's going on here? All right, go ahead and check your work. So 1 and 2 should have worked out, and 3 and 4, or sorry, 1 and 2 should not have worked out, and 3 and 4 should have. Just be careful with these negatives. So if you look at 4, don't forget that's a -2 up front, and then a -3 times a -7 should be a +21. So we want to be really careful with those negatives. Okay? So that's how to check if it's a solution, but how do we know what all the possible solutions are? Because I was telling you it's more than one. Well, let's look at how to graph this thing. So you're going to see that when we graph our linear inequalities, it's going to end up being a shaded region and an unshaded region. And the unshaded region is going to be where no solutions happen, and all the shaded region is going to give you all possible solutions. Okay? And that's going to be what's called a half plane. So we're basically cutting the coordinate plane into two pieces. One side is all solutions, the other side is no solutions, right? So no solutions are going to be here in the white area. Okay? So what you need to do is you need to be very careful with graphing your line, of course, and then there's going to be a boundary line. So notice here in the steps, the boundary line is going to be dashed for just a regular less than or greater than, But if it's greater than or equal to or less than or equal to, it's going to be solid. The dash is basically a way to represent open circles. And then the solid line is a way to represent closed circles. So if we have a dashed line, no solution is actually on the line. But if it's a solid line, then the solutions can also be on the line. So again, it's just a collection of open and closed circles. Okay? And then we want to test a point to see what side we shade. So why don't we do a couple as an example, and then you guys will try out the you-try problems. Okay? So if I take a look at the problem in D, the first thing I do is I just imagine, well, what would this be as an equation? Well, this is basically y equals -3. So I know it should be a horizontal line at -3. So let me put in some values here. I'm going to go by ones. And then before I go ahead and just graph my line at -3, I'm going to think, okay, what kind of circles do I have? What kind of line is that? So it's solid. So I'm using, sorry, it's less than or equal to, so it's a solid line. Meaning everything on y equals -3 could be a solution. So basically this is saying, hey, these are all solid circles, right? So when I connect them, it'll all be one solid piece, okay? Then we want to make sure we're testing a point that is not on the boundary line, because we already know if the boundary line is a solution or not. Right now, we already know everything on that red line is a solution. So let's go ahead and test some other point, and when I can, I like to test 0, 0, because 0, 0 is a super easy point to use. So I'm going to plug in 0 into the original inequality, y is less than or equal to -3. There's no x, so I'm not going to worry about it. So is 0 less than or equal to -3? No. So that means 0, 0 is not a solution. So if it's not a solution, do I want to shade it? I don't. I want to shade the side that includes the solutions. So this bottom region is the solution area, and then I'm done. Okay? Same deal for E. So I like to, again, first consider what would this line look like if it was just a plain old equal, so x equals 2. Then I know, okay, it's got to be a vertical line at x equals 2. So let me go ahead and write in my number line. And then remember, again, before I just start drawing in those vertical lines, I want to think, what kind of line am I actually using? This is going to be a dashed line, because there's no equal to underneath it. So that basically means at 2, these are all open circles, right? These cannot be a solution. So that's why we have a broken up or a dashed line saying, hey, we actually can't be on that line. Now the question is, am I going to the left or to the right? So let's again test a point. And I can test 0, 0 because it's not on the line. So I like to pick 0, 0, but if you want to pick 1, 1, go for it. If you want to pick 4, 0, go for it, right? If you want to pick -1, -3, that's all fine. Just any point that's not on that current dashed line. Going back to the original problem, so not the equals. So x is greater than 2. There's no y, so don't worry about it. Is 0 greater than 2? No, it's false. So 0, 0 is again not a solution. So that means 0, 0 is going to be on the open side, and I want to shade the opposite of 0, 0. So here's my solution region. Okay? Finally, F, what if we move on from just horizontal and vertical lines? Same thing here. I like to consider this first as an equation, and then get my y equals mx plus b. So 3y equals 6 minus x divided by 3. Y equals 2 minus 1/3 x. It's the same thing as y equals -1/3 x plus 2. Then I'm going to go back and look at the original problem and say, what kind of line should this be? Well, this needs to be a dashed line. Okay? Then from here, I'm going to go ahead and graph. So I'm going to again write in my number line. Starting at +2, You're going to go down 1, right 3, or up 1, left 3, and those should be my points again, dashed, so I'm using open circles. Okay, and then let's test a point that's not on that line. And once again, I can test, oops, let me close that, I'm not sure what's going on. 0, 0 if I want, because it's not on the line. And I'm going to go test the original problem, the x plus 3y is less than 6. So I'm plugging 0 and 0. So 3 is less than 6, that's true. So 0, 0 is a solution. That means I want to shade the side that includes 0, 0. So I'm going to go below. And this is it. All right. So that's how we basically graph inequalities. I'm going to have you guys try 5, 6, 7, 8, and we'll come back and check your work. All right. All right, go ahead and check your work. So I didn't show all of my tests 4, 5, 6, 7, but you guys want to make sure you show it to me on your own. I wanted to show you the test for 8 because this is a situation where 0, 0 doesn't work because 0, 0 is on the line. So I picked any other point. I like to pick points that have 0, so I picked 1, 0. And I saw that didn't work, so I shaded the other side. All right, so please come back to class with questions. We're going to do the word problem together and then practice in class. Thanks for listening.